Hello, today we will solve a problem related to the hydrogen atom, its spectrum, the emission spectrum. The condition of the task is as follows. It is necessary to calculate the wave number for the first and third lines, which are observed in the Lyman series for this element of hydrogen. In order for this to be possible, we need to know the basic formula that I gave above, in which we can see familiar concepts such as Planck's constant, the speed of light, wavelength, and also, if we write down this value, we have an expanded formula in which the following points are present. There is a Planck constant, the speed of light, and the Rydberg constant, which is equal to 19678 centimeters minus the first degree. Also, inside the bracket, we can see the value of n, which we already talked about in the last lesson, that this is the level to which the electron descends, and m is the level from which the electron is displaced inward. So how do we calculate the wave number for hydrogen in this case, if this is the first or third line? So if the line is the first one, in this case, in order for us to calculate, and this is what we need to do to calculate, is units divided by lambda. We have to use the formula where there's a Rydberg constant and substitute in these values of mem and then n values that we can substitute along the Lyman line. So it turns out that the constant that we have to substitute is 109,678. Inside the bracket we substitute. So if we get this for the first line, then n is equal to 1. We square all this expression at the bottom. Minus, and from what line is it possible to go to the first line? Only from the second line. And so instead of n, we substitute units divided by 2 squared. If we make such a simple calculation, it turns out that the value will be as follows: 83,359. This will be centimeters minus the first, or we could write a value for lambda equal to 1 whole 216 multiplied by 10 minus 1/5 centimeters. So the first calculation is obtained. Now let's calculate the same thing for the third line that is observed in the Lyman series. So we have a similar calculation. And so we're substituting a constant here as well. 109,678. Now it turns out we need to calculate the transition to the first level, so units divided by 1 squared, but the transition is obtained from the third line, and so we must, instead of m, substitute here 4, because only from the fourth you can go to the third line, and it turns out to be 1 divided by 4 squared. So if we do the math here, we get 102. 823 centimeters minus 1, or if we want to calculate as lambda value, we get 9.725 times 10 minus the 6th centimeter. That's what our answers come out to be. To calculate and make a calculation in such a problem, you must know the basic formula, respectively remember the Rydberg constant and substitute correctly, knowing exactly from which line is possible transition to a particular line, which is formed in the emission spectrum of the hydrogen atom. I hope you understand how we solved the problem, and we will solve a similar problem in the next lesson. Goodbye.